So the title of this talk is Hierarchical 3D Adapters for Long Video to Text Summarization, and I will explain everything in the title, okay? And we will start from right to left, so video to text summarization, and then we'll move on to the adapters. Now, I should point out that this is joint work with Penelope Papalambidi, who used to be a student of mine and now has moved to DeepMind, and I'm pointing here towards this direction. And it was initiated by Markus Rohrbach, who was a scientist at Meta. Now he's moved to pastures new. But anyway, it was his idea, and I never believed that you can take video and spit out summaries, actually, in textual form. You'll see. But he made us think that this might be possible. And we'll see the extent to which it is possible. I don't want to overpromise too much. Okay, so how many of you have watched or know of the series, the sitcom called Friends? Okay, this is great because last time I gave this talk, it was in my department. And it was like all my students. And I go, who has watched Friends? And one poor guy raised his hand. And I go like, who doesn't know Friends? Okay, so apologies for those of you who have not watched this. This was a very successful sitcom. It lasted for 10 years. It made the people who acted in it super famous. But assume you have watched this, and I ask you, what happens in the last episode of Friends? So do we have somebody in the audience who has watched it and want to tell us what happens in the last episode of Friends? Nobody's brave enough. So I'll tell you what happens in the last episode of Friends. Ross is the guy in the red shirt, confesses his love for Rachel. They decide to resume. No, sorry, Ross is the guy in the middle. Ross and Rachel are the couple, the hugging each other in the middle. Ross confesses his love for Rachel. They decide to resume their relationship, while Monica and Chandler, the guy in the red sweater, adopt twins, that's why you see the pram, and move to the suburbs. And I color-coded all the protagonists in different color here. You see, and this is a sitcom, so we're talking about 5 people, but the point is that people can very easily produce these summaries if they've watched the episodes on TV. Now, have you heard of Port Charles? I do not expect you to know of Port Charles. It's a soap opera. It's aired in the US. It's a spin-off of another very successful soap opera in America, which I'm sure we don't know of. It's called General Hospital. Anyway, this Port Charles is a fictional suburb in New York, and it's about these doctors, but they're doctors with a twist because the plot is a bit supernatural. There are zombies that kill each other and eat each other and whatnot. It's quite interesting and fun to watch, but I don't think anybody knows this. Anyway, this is a summary of one episode of Port Charles. And I'm going to start reading this to you because I want you to realize how difficult the task is, in particular if you don't know the characters, if you haven't seen lots of episodes and whatnot. So Kevin is freed by Karen, who drops by the lighthouse. Rafe and Lucy try to persuade Ian to save himself by killing Joshua, but he refuses to even consider it. Who are these people? No idea. Allison provokes Reese into chasing her to the healing pool. You see, it's a hospital. There's a healing pool. And Casey lures Kaz there on the pretense of going to a party. Too many characters. After going into the studio, Ian learns that Joshua is planning to blow up the hot spring. Jamal, yet another character, helps Rafe and Lucy at the healing pool, and so on and so on. So at the end, Caleb senses that something is wrong with his family. So this could be Klingon. We don't understand. Things are happening. People are doing things to people. And we expect now a machine to produce this summary after watching an episode. The task is hard. Now, if you think this is kind of artificial, though, I have a case where we do this all the time. So we go to meetings, and we attend these meetings. And if I've missed a meeting, I can ask you to summarize for me what happened at the meeting. And this is an actual summary of an actual meeting that happened in my department. I've changed the names. Jonathan welcomed the new members of staff. They all seemed a bit shy, to be honest. After a round of introductions, we discussed how to attract people back to the office. A lot of silly ideas were put forward, such as paying for bus tickets and offering breakfast every other day. Caroline and Rob engaged in a heated argument. She was in favor of punitive incentives, whereas Rob preferred to organize fun activities. Peter tried to calm things down, but was caught in the crossfire. The meeting was interrupted by a fire drill that happened. The discussion continued on the pavement, where Angela slipped and hurt her back. A lot of action in this meeting, but we can do it. Anybody can summarize. Okay, so what is this task specifically? So this is an instance, if you take the TV series or if you take the meeting, of a dialogue summarization task, because people talk. You have multi-party dialogue, you talk, things happen, and now we want, to take something that lasts an hour and condense it in a few sentences. This task has some features that make it rather hard. First of all, the input that a machine would have to deal with is quite long. It's approximately 115-minute videos. If you take the series, we'll see what data set we're using and what not. Friends episodes are shorter, but we are having longer episodes. It's 23,000 words. So this is like a mini book, and it's one episode. Aside from the long input, there is complex semantics, and there is long-range dependencies, and we need to understand who is talking, why, and so on. There is relationship between the characters. We saw in the Port Charles summary, we understood nothing, because we don't know the background, right? And so the machine would have to build this background somehow. Because we want to do it in a multimodal fashion, we will not just use the text. So we want to use the video, the language, and the audio. And this, of course, gives us extra complications because these different signals are different modalities. And somehow we have to map them into something that the model, which there's no surprise is a neural network, will have to understand. Another problem is that I cannot create a humongous data set and let your transformer or GPT or whatever model you want, let it loose. There is no data. We need videos, we need transcripts, and we need lots of them. And this is a challenge. Go and find. They're not out there. So we will always not have a lot of data for this problem. Maybe the data, there's a lot of data in the sense that the video is very long, but there aren't a lot of instances to train on. Okay, so the modeling has to take that into account, that, data will always be sparse for the specific task. And then evaluation is problematic, and I've shown this to you with the summary in the beginning. How do you know it's a good summary? You need to know stuff about the people, about the protagonists, about who did what to whom. So this is another problem. I'll put it out there. So these are a whole list of problems that we need to deal with. And now, whenever I give this talk, I see people nodding and going like, okay, there is this misapprehension, I think. People think that summarization is a solved problem. Okay, people think that, I can put like some document in ChatGPT and I get a summary. And it's also reflected in the fact that a lot of people have been working on summarization. The first publication ever was in 1958. It's by this guy, Loon, who created a rule-based system to do summarization. And you see the trajectory. Summarization was not popular at all for a while, and we jumped to 2022, and suddenly we have exponential growth. Of course, the conferences are bigger, so this is a bit, I'm not normalizing by the number of papers submitted to the conference, but this is a very healthy-looking area in terms of participation. But what people mostly focus on is text summarization. So text in, text out. Our task is multimodal. So we have some text. Here I show, how do you do this? Okay, this is a screenplay. If you don't have the screenplay, you can have a transcript, which is basically you transcribe what people say, what the actors say. So we have some text, but we also have the video, and we also have the audio. And I get asked often, do you use music? And no, by audio we mean stuff that people speak. And I would very much like to use music, and I can answer this question why music is not involved yet. But again, there is 3 modalities there. Okay, so let me contextualize a little bit what people have done in this space and where we're coming from. So there is text-to-text, where I would say 80% of the work has focused on summarizing news articles. But luckily, now we're moving towards other domains, such as dialogue summarization. So this data set here, Samsung, is on dialogue summarization. And SummScreen is a data set focusing on TV series. So they've taken the transcripts of episodes like Friends or Port Charles, and they've created a data set with very long inputs and summaries. So these are instances of dialogue summarization. Then you have the field of computer vision, where people do video to video. So you have video in and video out, no text. They don't care. They don't assume the text is available. And you know, if you have a YouTube video and it's all the stuff that happened to me in 24 hours, there is no transcript. There is nothing. So you can just cut it and summarize it, and this is what people do in computer vision. And then there is the hybrid area we're looking at, where we have video as input and text as output. And there have been 2 instances of data sets that have been useful. One is TACOS, where you only have video as input, but very few samples, so you cannot actually do learning. And the other one is HowTo, which has short input and short output. So the summaries are 1 sentence, whereas our summaries are much longer. So what I'm going to do for the rest of the talk is we're going to create a new data set on top of this SummScreen data set. So SummScreen is just transcript. We will enrich it with videos so that we can do our video to text summarization. Okay, and there are some nice features about this. The summaries have multiple sentences, so it's not like just 1 sentence, because really you cannot be summarizing something that takes, you know, you watch it for an hour with 1 sentence. And it's not humongous, but it's good enough to at least be able to do some fine tuning. So it has 4,500 samples. Okay, so let me just concentrate a little bit on how we go about modeling this whole task. And this is a question I just want to get it out of your heads. So this is a graph that shows all the large language models that appeared since GPT-3. And it doesn't include here GPT-4 or 3.5. It stops at ChatGPT, okay? And this is a trajectory, and we start at 2021. And now we have 2023, and still there is, I mean, this has not been updated. They're mushrooming. Okay. Now, if you know a little bit about this, what is the most sort of outstanding thing about this figure? The outstanding thing about this figure, aside from the fact that there's so many, is that very few are publicly available. The other ones are proprietary. You use an API, and you do stuff with the API. Why am I saying this? It is important for us to actually be able to change the model itself, because all of these models have been created with text in mind. There are some, now GPT-4, for example, potentially can deal with multimodal input, but all of these things are on text, and we need to go inside the model and actually tell the model, please, you have to look at the multimodal information. So we will use something which actually is not proprietary and we can play with, which I think is great, because some of us actually care about models rather than just applying them to things. Okay, so there is a hypothesis throughout the talk that incorporating information from the video and the audio will facilitate multimodal summarization of the dialogue. So we could have done this task by just looking at the transcript. But what I'm saying to you is that no, you need to look at the video, you need to look at the audio, because it will give us information which is not in the text. And how we're going to build this model, there is representations on audiovisual stuff. So you see here there's clip that has been trained with images and text. Slow fast is another model that is used for classifying video into actions. And YAMNet is particularly for speech. It classifies sounds like barking or sneezing. So we have these strong audiovisual representations, and you can take your favorite transformer end-to-end model, T5 or BART. Here we use BART. And in particular, we use BART because it has been trained and fine-tuned with a summarization task in mind. So we will take a model like BART, which is not small. The biggest variant is 11 billion parameters. And this has an inductive bias for summarizing text. So we don't want to miss that bias. We want that because we want to summarize this. And now the rest of the talk becomes, how will we get this text and summarization aware model to pay attention to the multimodal information? Okay, yes, and there is synergies between them. I said all of that. The final point is that I cannot just let BART to run loose on the data because I don't have enough data. 4.5 thousand samples of video and summary text is not enough. You cannot train from scratch, but even for fine-tuning, it's not enough. So we have to be a bit clever in the modeling and use these adapters, which are parameter efficient, to actually fine-tune the model. And I'll explain all of that. Okay, so these are the challenges here. I started by saying there is no data. I will give you an example of how the data looks like so that you understand, and then I will move on to the other challenges and how we solve them. Okay, so the original data set has transcripts, which is dialogue like that you see here. People speak. And it's paired with summaries that people who have time and have watched these things have posted on the internet. Okay, and usually it's one summary. And now we've taken this data set and have gone to YouTube. And it turns out that a lot of these episodes are on YouTube. And you can get the entire Poor Charles episode. So we will pair now the transcript with the YouTube episode with the summary. And this is the data that we are dealing with. And our input is going to be the video and the transcript, and our output would be a beautiful summary. Beautiful. I mean, they're not beautiful. You'll see. They're okay. Okay, so these are some statistics. I don't want to bore you with them. Important point is that we have some 4.5 thousand episodes, and this is 1 million video shots. So these are segmentations of the video, which is okay. It's enough. And we paired this data set. We have more than one summary per episode. So more summaries means better for evaluation, but also because summarization is not a task where you have one answer. Two people see the same episode and may give you different summaries. There is that problem as well, on top of everything else. Okay, so we talked about the data set. Now, let's discuss a little bit about the different input sources and how we're going to get the model to actually learn. Okay, so let me explain a little bit what, if you have never seen this data, what we are dealing with. So, and I'm going to simplify this. Although we have TV episodes, let's assume this is done for a movie, which is like 1.5 hours. So usually what happens is somebody has a concept of a movie or of a TV series or whatever. And here it's The Shining by Stephen King. So Stephen King wrote apparently this book, The Shining, which he didn't think much of. And then there comes some other person that takes this concept and thinks about writing a screenplay. And usually when people do that, professionals, they have a narrative structure. They say, okay, I'm going to start my hero by thinking that everything is okay. Then there will be some difficulty, some trouble. Then there will be danger. All hell breaks loose. This is true for The Shining, the movie, if you've seen, or the book, if you've read it. And finally, there will be some resolution. And usually people structure this. And once there is a structure in their head, and it's usually centered around the protagonist, Here, in this case, is Jack Nicholson, who is the main guy in the movie The Shining. And then you sit there, once you've done all of this in your head, and you write the screenplay. Now, we don't have access to screenplay. We have access to the dialogue. But the screenplay, you see, there's some instructions about where the camera is looking at and whatnot. So once we have the screenplay, then the next stage is actually making the movie, where we will have the actors, they will know their lines, and we film this thing. And once we get the movie, then we break it down into video shots. And this is where I come in, because we are only working after we've taken the movie and we've segmented it into video shots and aligned them with utterances. So what we are working with, what the model will learn from, is these things here. A video shot, which is some seconds, paired with what this person is saying. In this case, I can remember that when I was a little boy, my grandmother and I would hold conversations entirely without ever opening our mouths. Okay? And then there is another shot that is paired. And so these are the units which will be fed into the model to output the summary. Is that clear? Because this is the point where I lose the audience. Okay. Right. So let me show you how a standard encoder-decoder transformer-based model does summarization without any multimodal stuff, just on text, to sort of have an idea, and then I'll explain how we enrich this. So your usual BART model, which has been fine-tuned and knows how to summarize, will take as input a sequence of tokens, and they are denoted as X here, okay? And it will have some layers, some different blocks. First, it will contextualize these tokens using self-attention. And then we have this feed-forward block. And then finally, we get the hidden representations. And this is done over these L different layers. This is a hyperparameter. And then once we get the hidden representations of the contextualized tokens, we feed them to the decoder. And the decoder works very similarly, except that it has two things that are of importance. This cross-attention mechanism, where it decides where to look at in the input to summarize, because not everything in the input is important. And it has this masked self-attention, which again is quite important to concentrate on which tokens we want to summarize. So we have masked self-attention, we have cross-attention, and then we have the feed-forward layer that maps all these representations onto these tokens to output. And we train this model using this negative log likelihood objective. Basically, we output a token at every time step, given what I've generated so far and my input. And this is all done on text, okay? And now the question is, how can I change all of that to actually make it take into account these things here? The video shots, and the video shots have audio as well. They're not only video, and the text. Okay, so the way we will do it is we will do it in a parameter-efficient way, because I don't have a lot of data to fine-tune the whole model. And I'm going to insert these adapter layers, and these are the only things that will be trained. Everything else will be frozen. Okay, so we have this big model, and I'm only going to train the adapters. This is the general idea. And the next thing that I'm going to do is I have to give the model as input some multimodal information, else there's no point, right? Okay, and so the question is now, how do I insert this multimodal information? And I'll tell you why it's problematic. The whole model works token by token. I don't have tokens. I have video shots and utterances. So how do we deal with that? We could break it down, not great, because you cannot have a token of a little video shot. So we will actually deal with the utterances as utterances. And what we will do is we will have a global token that will represent the entire utterance and the video shot. Okay, so this global token, we will prepend it at the end of the utterance. So the model encodes token by token, but knows when the utterance finishes. Then I have a global token there that says multimodal information is coming. And then I need to learn a projection and fuse this information so that the model can take it into account. Is that more or less clear? Okay, so now the question remains. BART has an inductive bias which tells it to summarize. What guarantees do I have that this model will actually pay attention to this global token? Because it has not seen it before, right? So what would be the easiest for the model to do? And these are neural networks, yes?
Some instruction data.
You could use instruction data, yes, this is a good point. But if I don't do anything, the model will ignore the multimodal information, even though I've given it to it. So I need to somehow force it to look at the multimodal information. And how do we force this? Well, this is the global mask token. I have an extra loss that masks part of the input. So I will insert some noise in my input, and then I will add this loss that reconstructs this noise or removes this noise while the model is being fine-tuned. And what this loss would do, the E stands for encoder, and what this loss does is it tries to sort of use all the information to reconstruct the input. And that's how I force the model to pay attention to the multimodal information. Okay. So now the final thing, and then I'll talk about some results, and then I'll finish and take questions. I started my talk by saying these are hierarchical 3D adapters for summarization. Why are they 3D and why are they hierarchical? 3D are because we're taking we're taking the audio, the video, and the text. Why are they hierarchical? So a problem with these movies that we are dealing with is that there is very long-range dependencies. A character can be doing things at some other character, and they're all revealed at the end, and we actually don't know the dependencies, but we know they're very long-range. So we need to somehow tell this adapter, which the only thing that we are actually training, look, you need to take into account the fact that there is contextual dependencies between these multimodal informations, this multimodal information we have. And this is done with these hierarchical 3D adapters, which is a fancy word for basically contextualizing multimodal information. If you're familiar with the attention mechanism that contextualizes tokens, this 3D adapter contextualizes multimodal information. So here, I mean, the picture is not my best picture ever, but what you need to see is that we have these U vectors. These U vectors are multimodal and utterance level. By contextualizing, we take the dot product between all the multimodal vectors in this model. Through the dot product, we understand which ones are very related. These are all assumptions that we're making, that, you know, this dot product will reveal the similarity between multimodal information pieces. And then this is vanilla adapter stuff. We down project, and then we up project, and then we finally get this representation. The important thing to get out of this is that we have a way of encoding which multimodal vectors are related, and we do this with a mechanism very similar to the soft attention. Okay, so I've talked about data scarcity, I've talked about the data set, the different input sources. Now, one thing that I have not discussed so much, and it turns out it's very important, is that no matter how good this adapter is, there is a fundamental problem that the input is very long. And this is a huge cottage industry in NLP. How do you deal with very long input? And every week, literally, there is another paper presenting a variant of attention. There is sparse attention, there is local attention, literally. And nothing really has caught on. out of all these papers, people still do, and everybody starts these papers, attention is quadratic, you cannot do it, but still everybody's using it. So the question is, how can we actually deal with this very long input efficiently? Because we need to be able to represent it and encode it and everything. So there is a few solutions that you can do, aside from taking a model that is particularly, whose architecture is such that it can encode the entire input length. You could just select some pieces randomly. You have your video, select randomly some things, hope for the best. You can do a retrieval kind of selection where you take every utterance, compare it to all the other utterances, and then select the k-best with BM25. You can have a supervised model where you infer silver standard labels. So you have your input, you have the summaries in training, you do some alignment between the summary and the input. Things that are aligned, you assume are positive labels. Things that are not aligned, you assume are negative labels. You put a head on top of this classifier, you train your model, and you do supervised content selection. That is reasonable. Another thing which my student Nelly did is define a content selector based on this theory of turning points. Now, have people heard of turning points? No. Okay. So apparently in Hollywood, turning points are very famous. And if you are if you write screenplays for a living, everybody follows this turning point theory, which says a successful Hollywood, I don't know what happens for Bollywood or other sort of, or European, my God, European art house movies. But in Hollywood, a successful movie has to follow these turning points. And you see them here. And they're not arbitrary. There is this whole field of narrative theory that assumes, and it goes back to Aristotle, it assumes that all successful narratives follow this structure. So you will start with an opportunity. It's like the meet cute, maybe, you know, if you, in Hollywood. So there is an opportunity, and then there is a new situation where the plans change. And then the protagonists commit to their goal. And at this point, there is a point of no return because, you know, you have to pursue your true love interest, for example. And then complications happen. Things don't go as planned. There is a setback. Your love interest doesn't want you anymore because there's somebody else who is prettier, richer, whatever. There is a final push, a climax, and the aftermath. So many Hollywood movies, not only romantic comedies, even horror, subscribe to this structure. And the idea is we will actually try to identify this in our series. We have in other work, I'm not going to go into the details here, but I'm happy to answer questions. We have a classifier that takes the movie or the series and inserts these breaks. Think of it as a segmentation task. So it will tell us where the opportunity is, more or less. You know, there is a window around this segmentation point, and then the change of plans and whatnot. So the idea is using this strategy to just select points in the video that are around these turning points. And this is the input that we will give to the model. Okay? And this is an example here. Again, we have the screenplay or the transcript. We have the video, the audio, and we insert these turning points, and then we take, you know, a window around these points. Okay, let me present some results. Now, another problem, a very sticky issue, is evaluation. And I have some slides on this. What people normally do in summarization is they report this metric called ROUGE. Can I see a show of hands? How many people have heard of ROUGE? Okay, not very many. Okay, so ROUGE is a metric that takes a gold standard summary and a model summary and computes how lexically similar they are using some overlap metric, which can be unigram, bigram, whatnot. Here we report ROUGE-L, which takes longer sequences into account. Now, there has been a lot of work recently, if you're paying attention with ChatGPT summaries and whatnot, it turns out that this metric was invented 20 years back when the models were not that great and not that fluent. And nowadays, if you run ROUGE on very fluent text, it's not very reliable. And it's not a great metric, and I really don't care for it, except that you cannot publish papers without actually using it. OK, so I'll show you ROUGE and then an alternative. So here we have two models. These are just text. We haven't gone to the multimodal version. And this LED is a long former. This is a model that takes all the input into account. It has this local sparse attention mechanism, and it's supposed to be good at handling very, very long documents like the ones we have. And dialogue LED is even better. It's the same model, but particularly fine-tuned for dialogue. Okay? And you see they obtain a ROUGE in the region of 31. Does this mean much to you? What does it mean to have? I'll quantify this. A ROUGE of 60 would be amazing. A ROUGE of 2 is bad. We are somewhere in the middle range where we get some words correct, but we don't know much about what the summary means. OK, so these are models that are particularly suited for long inputs. And then we have a vanilla BART model. This does not take into account very long input. We stop after, I think, 1,000 tokens. So these are fully fine-tuned. And then we have a BART model with adapters, just adapters, not multimodal adapters. So it has been fine-tuned on our data set. But again, we don't have any multimodal information. And then finally, we have multimodal BART, which is what I was advocating from the beginning, that we need the multimodal information. And you see, even though ROUGE is imperfect, when we take the multimodal information into account, we get, according to this metric, better summaries. OK, so again, our problems. Now we'll discuss a little bit evaluation, which is how can we know that the model generated a good summary if you don't believe ROUGE? OK, so let me show you a gold summary here. So it's again about Port Charles, and we have this character, Caleb, who is upset because Livy tells him that Joshua has the ring. Remember, there are vampires. There is a lot of action happening. So the idea is to actually go into this gold summary and identify the entities. And by entities, we mean important things that either proper nouns or nouns that indicate something about what is happening. So we identify these entities, and then we generate, using a model, a T5 model or whatever, and then we generate questions about these entities. So, for example, who does Karen realize is a vampire? Frank. Who pleads with Victor to fight Joshua? Lucy. Now, even if you don't know much about this episode, you can understand by these questions what the summary is about. You get a rough idea. And you at least can understand whether you get the relations correctly. So we do this on the gold summary, and we get a set of question-answer pairs, gold, that are the basic information units for the summary to answer to. Now, then we get the model, and the model outputs a model summary. And then we're going to try to see, given this summary, can I answer my gold questions? And in this case, you see that it answers 4 correctly and 3 not so correctly. So this is a better metric of the information that the summary captures. And I'll show you some results with that, and I'm almost done. I have like a couple of more slides, and then I'll take questions. OK, so this is a question answering based evaluation. And I am showing you these different methods of selecting the content. And the first thing that I want you to notice is red is multimodal model, and gray is just text. And throughout, multimodal information is much better than just text. OK, so we park that. We need multimodal information in this domain to be able to do the summarization task. Now, which model is best? So first of all, let's start with Oracle. This is like an upper bound. So it's around 30%. And then we have random selection, doesn't do very well. The turning points and the supervised content selector do very similarly. The supervised content selector is some percentage more, which is good news. It means that we can actually do content selection and we don't miss much if we can find the right information. Now, let's compare to these models that actually take long input into account. So here we have again the long former and the dialogue LED, and this is QA eval again, based on the question answering task. And these are very memory heavy. They deal with long sequences. You have to wait a few days for training to finish. And here we have multimodal BART, and they're fully fine-tuned. And multimodal BART does better, significantly better. All the differences are significant. And the interesting thing is that we've only tuned 4% of the model parameters. So this is a lot more data efficient, time efficient, everything more efficient. Okay, so let me conclude. So I've introduced this data set, which is built on top of this other data set, which uses video, audio, and text. And please use it. I advocated that parameter-efficient models are particularly suited to this domain where data is scarce and there will never be enough. I've also shown that multimodal information is critical for this task of dialogue summarization, where you have people speaking and events and actions and whatnot. And interestingly, content selection outperforms sparse self-attention variants. And I'll stop here and take questions.
Thank you very much, Mirella. Let's start with questions. Chen?
I have a question regarding the turning points.
Yes.
I wonder what's the distribution of information or content associated with the segments of each of the turning points? And do you consider those turning points equally important, or there's some of them are more important than others?
That's a very good question. Okay. So again, there is a rule of thumb in Hollywood that says the opportunity has to happen no later than 20% in. So these are all spaced in specific locations. They have sort of a fixed distribution. And in fact, the classifier, the turning point identification, takes that into account, and this is a prior with which it is initialized to be doing that. Now, regarding to which ones are more important and which ones aren't, this is another excellent question. It depends a little bit on the task. So we have done this analysis, and if you do trailers, so we have some other work where we actually generate the trailer for the movie. Now, for the trailer, you don't want the climax. This is very bad, right? And probably you need a little bit of the major setback or not. So there is a heavy bias towards the beginning of the movie, even for the summarization task, because there's a lot of background and a lot of things are said in the beginning, not towards the end. Yeah, that was a very good question.
Thank you.
Mark?
Yeah, thanks for the interesting talk. So the question-based evaluation looked like a really interesting alternative to ROUGE. Could you say a bit about how you set that up? Did you have to identify the questions manually?
Yeah, I didn't talk about this. Yeah, very good point. Okay, so nothing is manual, but it involves work. So here, okay, so first of all, we identify named entities or entities. I have not highlighted here Caleb and Levy, but it's a typo. We would identify these named entities, and then we use a question generation model, and in this case, we downloaded a T5 trained on squad question generation model, where you give it the gold summary as context and the ring, let's say, as an answer. And we tell the model, given this answer in this context, generate a question about the ring. And so that's how these questions are generated. This is first part. Second part, which I did not talk, and thank you about, and thank you for the question. When we have the test phase, we actually do question answering rather than question generation. So given that we have generated these questions, we need to see if the summary answers them. So now, given the question answering task, we have this question, and we have this summary as a contextual unit. And again, we use a squad trained model for question answering this time to find the answer to the question. And then we match the two, and if they match, we are successful. If they don't match, they don't. Yes, so I did not discuss this in detail, but this is, yeah, you have to do question answering and question generation. But we can do this nowadays. We couldn't. Like, we have like Hugging Face, bless them. You can download everything from there, and like the stuff works, and it's like 2 lines of code. So yeah. Any other questions?
Fantastic talk.
Thank you.
So I have many questions, but I think I'll just pick a few. So for the features, the multimodal features, what model do you use to like extract those like token representations?
Yeah.
Then, like, after the content selection, like how many like features or frames do you do you give to this model? Like,
Yeah, these are all good questions. I didn't talk about this. Yeah. Yeah.
Do you find any overfitting problem?
Overfitting, yes, it overfits. These are brilliant questions. I mean, you can tell he works on the stuff. So we extract, so this is a concatenation of these 3 representations: clip, slow fast, which is for video, and YAMNet, which is the audio. So we concatenate these, and then while the adapters are fine-tuned, we down project them and we fuse these representations. And importantly, they are not per token, they are per utterance, right? So we don't have individual tokens, although you could do that, but it would contribute to the overfitting problem massively. What was, you had a middle question?
So how many like multimodal actual tokens are given?
Yeah. So in the shots, how many shots we have there? 900 shots per video, right? So if you had this, okay. Oh, sorry. Where is the? I had this picture, this nice picture. Hold on, here. Okay. So these are aligned, right? We use dynamic time warping to do the alignment, and then per instance, per training point, we have approximately 900 of those.
How long is one shot?
A few seconds. And of course, there is, you can have many shots. You can have, and this is another parameter that we play with. You can have many, you can have few, depending on the segmentation algorithm and whatnot. Yeah.
And lastly, do you see any overfitting problems?
Yes, so we saw a lot of overfitting problem. I mean, overfitting is a problem because the data is not a lot, okay? And there is things you can do with the temperature and whatnot to avoid the overfitting. And because we see overfitting, we had to move to the adapters. If you don't use the adapters, it will not learn. In fact, it didn't learn in our case. Yeah, that's a very good question.
Hi, thank you for the talk. I mean, you're using the transcript as ground truth and then assessing the outputs from the video and the audio. So hypothetically, there could be a possibility that one of them, there is a discrepancy and it doesn't match with the ground truth.
This is not a possibility, it's a reality. Yeah.
And in that case, hypothetically, it's also possible to identify which particular aspect of that video clip had the discordance. And then my question is, how do you go back to that particular clip and retrain to improve the performance?
Yes.
And my second question is, if you don't have the transcript, which means that you don't have the ground truth, and then you run the model, how do you weigh which of the outputs should, have more weightage, like the audio or the video?
Perfect. You guys were paying attention. This is, or maybe because this is a multimodal workshop, these are excellent questions. Okay, so it's true, these cannot always align because it's heuristic, we try to align, and there is noise. So it can happen that you have a video shot that does not correspond to the utterance, and we don't do anything. So if we were more sophisticated, we would have to detect it and remove it or correct it. This is some level of noise we can live with, or at least we tell ourselves that we can live with. And this is very problematic also when you're doing turning points, because you get a boundary wrong, and if it's misaligned, then you're kind of screwed. We don't have a way of dealing with it. You could devise something with some supervision to detect these things and remove them, future work. Your other point about how do you weight audio versus video versus text, and how we have done all these experiments. If you don't have, text is the most important modality because it's what these models are fine-tuned on and trained with. And so, but if you don't have text, then actually it depends a bit on the genre. So if you are doing movies, audio is more important. For this series, because there is action or whatever, then the video gives you a huge boost, not so much audio. But I cannot say that this will happen for every kind of series or whatever. It is a bit dependent on what problem you have. Also, it's not the same for the turning points. For example, we found that we need to identify the turning points. You need both audio and video. So it depends.
And let's take the last question before we go to lunch.
Hi, thank you for the talk. Earlier on, you mentioned about summaries of meetings. I was wondering, meetings or press conference, they wouldn't have turning points, and we thought about.
Good question. Yes, yes. So that's actually brilliant. Yes. So the question is, I've talked about, how we would summarize meetings, and then I told you we are doing turning points, and obviously meetings are not like narrative artifacts. There is no turning points. If somebody is running the meeting properly, there is some structure. So, for example, there is an agenda, and you could at least do the segmentation with the agenda, right? However, sometimes meetings get out of hand, in which case, yeah, you're better off doing something like BM25 or have some supervised thing. But again, I would be very surprised if there is not some sort of location bias that you could use. Like, given an hour-long meeting, there is the beginning and the end. You definitely need to extract those, because the end probably summarizes some action. So there is some domain knowledge you could use. But yeah, you're absolutely right. No turning points.
A very interesting discussion. Let's thank Mirella again.
Thank you. Thank you.